What if the past, present, and future all exist at the same time? Discover the mind-bending truth about time, space-time, and the block universe. Imagine two people passing each other on a quiet street, one walking east, the other west. There's nothing remarkable about the scene at all. Now imagine that exact same moment, but think about what's happening 2.5 million light-years away in the Andromeda galaxy. According to our best physical theories, those two people, simply by walking past each other at normal speed, could disagree by several days about what is happening right now in Andromeda. Not about what they can see, not about what they can measure, but about what they would call now. Just by moving in opposite directions, their sense of the present could differ by days. That sounds absurd, like an error or a trick, or a basic misunderstanding of time itself. But it isn't. Special relativity predicts exactly this, and it has been tested with extraordinary precision for more than a century. This video is about that idea. We're going to explore one of the strangest and most unsettling concepts in all of physics, the possibility that the future already exists. That your tomorrow is just as real as your yesterday, and that the flow of time itself may be very different from what you've always assumed. This view is known as the block universe, and some physicists and philosophers call it eternalism. If it truly reflects reality, then your experience of time, the feeling of a present moment moving forward into an open future, isn't quite what it seems. I want to be clear from the start. This is a topic where the physics is solid and well tested, but the philosophical implications are still debated. I'll separate what the equations tell us with confidence from what remains a matter of interpretation. The goal isn't to persuade you that one view is correct, but to show why serious physicists take these ideas seriously and what they would imply if they're true. If you enjoy this kind of deep exploration, if you like taking the time to sit with ideas that challenge how you understand reality, consider subscribing to the channel. It helps these explorations reach more curious minds and lets me know this is the kind of content you want more of. Now, let's begin. To understand why physicists talk about time in such strange ways, we first need to see what time meant before Einstein, what everyone assumed was obvious, and why his work shattered that assumption. For most of human history, time seemed almost trivial, flowing from past to future. The present moment was real and happening now. The future hadn't arrived yet. These ideas felt so obvious, they barely needed to be stated. In 1687, Isaac Newton's Principia laid out the laws of motion and gravity, with these assumptions built directly into their foundation, treating time as absolute and flowing uniformly everywhere at the same rate for everyone. If it's 3 p.m. here, it's 3 p.m. everywhere. The present moment is universal, and this matched everyday experience perfectly. You and I might disagree about many things, but not about whether something is happening now, or in the past, or in the future. Those categories felt as real and fixed as the objects around us. For more than 2 centuries, this view formed the bedrock of physics. Time was time. Simple, universal, absolute. That changed in 1905. A 26-year-old Albert Einstein, working as a patent clerk in Switzerland, published a paper that would transform our understanding of reality itself. It introduced what we now call special relativity, and hidden within its mathematics was a revelation that challenged everything we thought we knew about time. At the heart of Einstein's insight was careful attention to a single, simple fact. The speed of light in a vacuum is always the same. It doesn't matter how fast you're moving or how fast the source of the light is moving. It is always 299,792,458 meters per second, or about 670,616,629 miles per hour. It never changes. That might not sound revolutionary at first, but think about what it really implies. If you're standing still with a flashlight, the light moves away from you at that speed. That feels intuitive. Now, imagine yourself on a spaceship traveling at half the speed of light, switching on the same flashlight and pointing it in the direction you're moving. Common sense says the light should now be moving at 1.5 times the speed of light relative to a stationary observer. Your speed plus the speed of the light. But that isn't what happens. The light still travels at exactly the speed of light, not 1.5 times faster, just the same speed as always. This completely violates our intuition about how velocities are supposed to add together. When Einstein followed the mathematics of what this constant speed of light actually implies, he uncovered something that shattered the Newtonian view of time. Simultaneity is relative. This idea is the key to everything that comes next. So let's slow down and unpack it. In everyday life, simultaneity feels obvious. Two events happen at the same time, so they're simultaneous. End of story. But Einstein's equations show that this picture isn't quite right. Two events that appear simultaneous to one observer may not appear simultaneous to another observer who is moving relative to the first. The mathematics is very precise here. It's captured by an equation known as the Lorentz transformation, which tells us exactly how observers in relative motion will disagree about when events occur. For two events separated by some distance, the difference in the times assigned by two observers is approximately equal to their relative velocity multiplied by the distance between the events divided by the speed of light squared. This isn't speculative. It has been tested countless times and underlies particle physics, GPS satellites, and many everyday technologies. The math works. The real question isn't whether it's correct, but what it means. And that's where things start to feel strange. Imagine two observers passing each other at a modest speed. Nothing dramatic. Just one person walking east and another walking west, with a relative speed of about 1 meter per second, roughly 2.2 miles per hour. Over ordinary distances, the difference in how they define simultaneity is tiny. If they're asking what's happening right now on the other side of the room, they'll agree to within a tiny fraction of a nanosecond. We never notice this effect in daily life because it's far too small to detect. But the formula tells us that the disagreement grows with distance. The farther apart the events are, the larger the difference becomes. So let's push this to an extreme. The Andromeda galaxy is about 2.5 million light-years away, which is roughly 2.365 times 10 to the power of 22 meters, or about 1.47 times 10 to the power of 19 miles. Now take those same two observers, still just walking past each other at 1 meter per second in opposite directions. When they look toward Andromeda and ask what is happening there right now, special relativity says they will disagree, not by nanoseconds, not by minutes, but by about 3.05 days. If one of them says, right now in Andromeda, it's Tuesday, the other, simply because of their slow relative motion, would say, right now in Andromeda, it's Friday. And here's the unsettling part. Neither of them is wrong. According to special relativity, there is no objective fact about which one is correct. At large distances, simultaneity is not something built into reality itself. It depends entirely on how you're moving. This result is often called the Andromeda Paradox, and it's used as a vivid way to show what the relativity of simultaneity really means when you take it seriously. Take a moment and let this sink in. Two people walking slowly past each other, disagreeing by several days about what is happening right now in another galaxy, with no mistake on either side. The disagreement is built into the structure of spacetime itself. I remember the first time this really clicked for me. I had to close the book and just sit with it for a while. Because if this is true, if simultaneity really works this way, then the present moment is not what we think it is. Now is not etched into the fabric of reality. It depends on perspective. Like the direction you call forward or to the right, it has real consequences. Now, let's talk about what all of this implies for the nature of time itself. In 1908, a mathematician named Hermann Minkowski took Einstein's equations and reframed them in a new way. Just 3 years after the publication of Special Relativity, Minkowski showed that space and time, which we normally think of as separate, can be unified into a single four-dimensional structure called spacetime. In this picture, the universe isn't three-dimensional space that changes over time. Instead, it's four-dimensional spacetime, with time simply being one dimension among others, no more special than the dimensions of space. An event in your life isn't something that happens and then disappears into the past. It's a point in spacetime with specific coordinates, and that point is just as real as any other. Your birth exists at one set of coordinates. You reading this sentence exists at another. Both are equally part of the same four-dimensional structure. When Minkowski introduced this framework, he made a famous remark about it. Henceforth, space by itself and time by itself are doomed to fade away into mere shadows, and only a kind of union of the two will preserve an independent reality. Space and time, taken separately, are shadows. The unified structure, space-time, is what's real. In this four-dimensional view, your entire life forms a world line, a continuous thread traced through space-time from your birth coordinates to your death coordinates, with every moment of your existence located somewhere along that line. The thread doesn't move through space-time, it simply exists within it. This way of understanding reality is known as the block universe, or eternalism. All of space-time exists together as a single block. Past events aren't gone, and future events aren't unreal. They're all there, each at its own location in the block. What we experience as the passage of time, in this view, is more like moving through a landscape. The landscape itself doesn't change. You simply find yourself at different points within it. Different points along your world line correspond to different conscious experiences, and you experience them in sequence. But that entire sequence exists all at once within the four-dimensional structure. This is a radical idea, and many people find it deeply counterintuitive. So why do physicists take it seriously? One reason is that the relativity of simultaneity seems to push us in this direction. This argument was made explicit by philosopher C. W. Reitdijk in 1966 and by Hilary Putnam in 1967. It begins with a simple question: what exists right now? If you're a presentist, you believe that only the present moment exists. The past has ceased to exist, and the future doesn't exist yet. Reality becomes something like a moving spotlight, illuminating only the present while everything else remains in darkness. This is how most people naturally think about time. The past is gone. The future hasn't happened. Only now is real. But consider what the relativity of simultaneity does to this picture. Imagine an event happening in Andromeda. Call it Event A. Right now, as you sit here, there exists some observer moving relative to you for whom Event A lies in their past. For them, it has already happened. According to their frame of reference, Event A is a settled fact. From your perspective, however, that same event might lie in your future, not yet having occurred. The key question is this: is Event A real? If you're a presentist, you might say Event A isn't real for you because it's still in your future. But another observer, who is just as valid according to the laws of physics, says Event A is real because it's in their past. The Reitdijk-Putnam argument claims that both observers must be describing the same reality, since there is only one universe. If Event A is real for one legitimate observer, then it is real, full stop. The argument goes further. If any event that lies in the past for some legitimate observer is real, and if there are legitimate observers for whom almost any distant event lies in the past, then distant events are real, regardless of whether they appear to be in our past, present, or future. In this way, the relativity of simultaneity seems to force us toward eternalism. And if there's no objective way to draw a sharp line between now and not now, then that distinction may not correspond to a real difference in what exists. I want to be careful here. This argument has been debated by philosophers for decades, and it's far from universally accepted. There are thoughtful responses and serious critiques of this line of reasoning. In 2021, Yaron Sheffer published a detailed critical analysis of the Andromeda Paradox, arguing that the usual metaphysical conclusions people draw from it aren't as straightforward as they often seem. The physics itself, however, is not in question. The relativity of simultaneity is real. The equations work. What remains debated is whether this really forces us to accept the block universe interpretation. Many physicists, when they reflect on the implications of relativity, find themselves drawn toward the block universe view because the mathematics appears to describe spacetime as a unified whole, with no objective present carved into it. Einstein himself seemed sympathetic to this perspective. In March of 1955, shortly before his own death, Einstein wrote a letter to the family of his close friend Michel Besso, who had recently passed away. In that letter, he offered comfort with a striking remark. He wrote that for those who believe in physics, the distinction between past, present, and future is only a stubbornly persistent illusion. An illusion, that's the word Einstein used. Not exactly wrong, but not capturing something objectively real about the world either. Think about what it would mean for the distinction between past, present, and future to be an illusion. Right now, you are experiencing this moment, and it feels completely real, undeniably present, unmistakably now. The moments you remember from yesterday feel like the past, gone, no longer real. The moments you expect tomorrow feel like the future, not yet real, open and undetermined. Einstein's suggestion is that this feeling, this sense of time flowing, is an illusion. Not in the sense that it isn't happening, but in the sense that it doesn't reflect the objective structure of reality. Compare it to the feeling of solid ground beneath your feet. The floor feels solid, yet physics tells us it's mostly empty space, with atoms held apart by electromagnetic forces. The solidity isn't exactly false, but it isn't what's fundamentally there either. The flow of time may work the same way, not exactly false, but not fundamental. If the block universe is correct, then what's fundamental is a four-dimensional structure containing all events, past, present, and future. Your life is a thread through this structure. Your experience of now occurs at each point along that thread, but the thread itself exists all at once within the block. This is the part that still amazes me, even after years of thinking about it. The idea that yesterday and tomorrow are both there, that they exist in the same sense that today exists, and that the difference between them is more like the difference between here and there than the difference between real and unreal. Here's another way to think about it. Imagine a novel as a physical book with all its pages present at once. Chapter 1 exists. Chapter 10 exists. The ending exists. All of them are equally real as parts of the book. Inside the story, the characters experience events in sequence. For them, there is a flow from earlier to later, with the events of Chapter 1 happening before the events of Chapter 10. But from outside the story, from the perspective of someone holding the book, there is no flow. All the chapters simply are. The beginning and the ending are equally present, equally real, equally part of the book's existence. If the block universe is right, reality is something like that. We experience it sequentially, moving through it page by page, but the entire story is there all at once. Past, present, and future are like earlier and later chapters, all equally part of the book of spacetime. The analogy isn't perfect. In a novel, the story exists from an outside perspective, while in reality, we are characters within the story, with no access to anything outside it. Still, the analogy captures something important: the difference between how something is experienced from within and how it exists as a whole. Now really consider what this would mean for your own life. If the block universe is correct, then the you of yesterday still exists somewhere in space-time, at the coordinates of yesterday. Not gone, just located elsewhere in the four-dimensional structure. The you of tomorrow already exists at the coordinates of tomorrow. Not unreal, just at a location you haven't experienced yet. Every moment of your life exists somewhere in space-time. Birth, death, and everything in between, all of it there. For some people, this idea is deeply unsettling. It can feel like it implies the future is fixed, that free will is an illusion, that everything is predetermined. For others, there's something strangely comforting about it. Everything that has happened is still there in some sense. Everyone who has died still exists at the coordinates of their life. The past isn't lost. And for still others, both reactions miss the point. The block universe doesn't necessarily imply determinism in the way people usually mean it, and it doesn't make the past recoverable in any practical sense. We'll explore some of these implications later. For now, sit with the idea. This is one of those concepts that rewards patience. Now let's go deeper, because as strange as special relativity is, it was only the beginning. In 1915, Einstein completed his masterwork, General Relativity. This theory extends special relativity to include gravity, and it makes the picture of space-time even richer. In general relativity, space-time is not a fixed four-dimensional stage where events simply play out. It is dynamic. It curves and bends in response to mass and energy. What we experience as gravity is, in fact, the curvature of space-time itself. This has profound implications for the block universe picture that emerges from special relativity. In special relativity, even though different observers disagree about simultaneity, you can still imagine slicing space-time into flat surfaces of now, one slice for each observer. Different observers slice it differently, but the slicing itself is still possible. General relativity makes this far more complicated. Many spacetimes that solve Einstein's equations don't allow any natural, global slicing into space at a single time. There's no well-defined way to extend a present moment across the entire universe. Some special spacetimes used in cosmology do allow convenient time coordinates. Our standard cosmological model, for example, uses a time coordinate that roughly corresponds to the age of the universe since the Big Bang. But this is a model-dependent choice, something we adopt for convenience, not something built into the deepest level of the physics. The mathematics of general relativity suggests that space-time itself is fundamental, and that any division into space and time is something we impose, not something inherent in reality. This strongly reinforces the block universe view. If space-time is what's fundamentally real, and if slicing it into moments of now is arbitrary and observer-dependent, then the four-dimensional whole starts to look like what truly exists. The three-dimensional present becomes just one way of looking at it. Let me help you visualize what this four-dimensional structure is like. We're comfortable thinking in three dimensions: length, width, and height. We can easily picture a cube or a sphere. A fourth dimension pushes our intuition past its limits. But here's one way to approach it. Imagine filming something simple, like a ball bouncing. Each frame shows the ball at a specific position. Now imagine stacking all those frames on top of each other, with time running upward. What you get is a kind of tube or trail that shows every position the ball occupied during the entire movie. That tube is the ball's world line. It's the complete four-dimensional history of the ball from start to finish. In the block universe, everything has a world line like this. Every particle, every object, every person. Your world line begins at your birth and ends at your death, with every moment in between represented as a point along that line. Now, imagine doing this for everything in the universe. All world lines are there, tracing through space-time, curving toward one another where gravity is present, intersecting when objects meet, branching when things split apart. The result is a vast, intricate, four-dimensional structure containing everything that has ever happened and everything that ever will happen. Past, present, and future, all woven together into the fabric of space-time. This is the block universe. There's an objection that almost always comes up at this point, so I want to address it directly. Doesn't this mean the future is fixed? Doesn't it mean we have no free will? This is a deep question, and philosophers strongly disagree about the answer. Let me offer one perspective that can help clarify things. The block universe, by itself, doesn't necessarily tell us anything new about determinism or free will. Here's why. Suppose tomorrow you make a choice to drink coffee instead of tea. In the block universe view, that decision exists at a particular location in space-time. The fact that it exists in the four-dimensional structure doesn't mean it was forced on you. It just means that whatever decision you actually make is part of the structure. The block universe describes what happens, not why it happens, or whether it had to happen that way. Those are separate questions. Think of it like a map. A map of your city shows all the streets and buildings. If you drive from your home to the grocery store, the route you take is already there on the map. But the map didn't make you choose that route. It simply represents it. In the same way, the block universe represents what happens in space-time. It doesn't, by itself, say whether those events were inevitable or whether alternatives were genuinely possible. Answering that requires additional philosophical arguments. Some physicists and philosophers do think the block universe supports determinism, arguing that if the future already exists, it must be fixed. Others respond that this confuses two different questions. Does the future exist? And is the future determined? These may be logically separate issues. I don't want to suggest this debate is settled, because it isn't. But I also don't want you to assume that accepting the block universe automatically means your choices don't matter. That conclusion doesn't follow without further argument. To get a better feel for the scale involved in all of this, let's look at some numbers. Light travels at 299,792,458 meters per second, about 670,616,629 miles per hour, or roughly 1,079,252,849 kilometers per hour. In 1 year, light travels about 9.46 trillion kilometers, or roughly 5.88 trillion miles. That distance is called a light year. The Andromeda galaxy is about 2 million light years away. To put that in more concrete terms, that distance is approximately 2.365 times 10 to the power of 22 meters, a 2 followed by 22 zeros. In miles, it's about 1.47 times 10 to the power of 19, a 1 followed by 19 zeros. These numbers are almost impossible to intuitively grasp. But here's what they mean for the Andromeda Paradox we discussed earlier. When two people walk past each other at about 1 meter per second in opposite directions, the difference in their judgments about what is happening now in Andromeda is roughly 3.05 days. Walking a bit faster, at a brisk pace of around 1.44 meters per second, increases the difference to about 4.26 days, simply by walking, not by getting into a rocket, not by approaching the speed of light, just by moving at normal human speeds. The reason the effect becomes so large is the enormous distance involved. The formula for the shift in simultaneity depends on two things: the relative velocity and the distance to the events you're comparing. Across a room, the effect is unimaginably small. Even across the entire diameter of the Earth, about 12,742 kilometers. With a relative speed of 1 meter per second, the shift is only around 0.142 nanoseconds. That's why we never notice it in everyday life. But across 2.5 million light-years, even tiny relative speeds turn into days of disagreement about what counts as now. Think about what this means for the idea of an objective present moment. If you and I can disagree by several days about what is happening right now in Andromeda, based on nothing more than how fast we're walking, then now in Andromeda is not an objective feature of reality. It depends on motion. It's relative. And if now in Andromeda isn't objective, what about now in the next room? In principle, the same effect applies. It's just far too small to measure. The lesson is the same. Simultaneity is not built into the fabric of spacetime. It's something observers construct, and different observers construct it differently. This is one of the deepest lessons of special relativity, and it took decades for its full implications to sink in. Let's shift focus to something much closer to home: your own experience of time. No matter what physics says about space-time, you experience time as flowing. The present moment feels vivid and real. The past feels gone, accessible only through memory. The future feels open, undetermined, not yet there. This experience is universal. We all feel time passing. We all experience the now as special. We all feel like we're moving toward the future. Where does this experience come from? Philosophers refer to our experience of the present moment as the specious present, the short window of time that feels like now. Psychological research suggests this window lasts about 2 to 3 seconds. Within it, events feel simultaneous and present. Outside it, they feel like the past or the anticipated future. So why do we experience time this way, and why does it feel like it flows? Modern neuroscience suggests that our sense of time is something the brain constructs. We don't perceive time directly the way we perceive light or sound. Instead, we assemble a sense of time from memory, prediction, and neural activity. Researchers have identified so-called time cells in regions like the hippocampus and entorhinal cortex. These neurons fire in sequences, creating an internal clock that helps us place events in time and distinguish past from future. Here's the crucial point. All of this happens inside the brain. Our experience of temporal flow is something our nervous system generates. It's a feature of conscious experience, not necessarily a feature of the external world. In the block universe picture, this fits naturally. If all of space-time exists at once, then what we call the flow of time is something that occurs within conscious minds located at particular points along their world lines. Each conscious moment experiences itself as now, with memories of the past and expectations of the future. But from an objective perspective outside the world line, there is no flow. The world line simply exists. This is a strange idea. It suggests that one of the most basic aspects of our experience, the feeling that time passes, might not correspond to anything in the physical world. The passage of time could be like the apparent motion of the sun across the sky, real as an experience, but not a literal description of what's happening. If time doesn't actually pass, why do we experience it as passing? This is a deep and difficult question. One answer, compatible with the block universe, is that each moment of consciousness along your world line includes experiences that feel like flow. Each moment contains memories of immediately preceding moments, creating continuity. Each moment also includes expectations about what comes next, creating the sense of moving forward. You don't need time itself to flow for this to happen. You just need each moment to contain the right mental states, the memories, the anticipations, the feeling of this is now. If those mental states exist at every point along your world line, then you'll experience temporal flow at every point. Even if the world line as a whole is static, it's similar to a movie. Each frame is a static image, yet motion emerges from the relationships between frames. The sense of time passing may work the same way. It doesn't exist in any single moment, but emerges from the structure, linking moments of consciousness along the world line. This is, of course, speculative. We don't fully understand consciousness or how it relates to the structure of space-time. Still, the block universe offers a framework for thinking about these questions, and many people find it illuminating. There's one more aspect of time we need to address: the arrow of time. Even if the block universe is correct and all of space-time exists together, there's still something special about the direction we call the future. We remember the past, not the future. We can affect the future, not the past. Causes come before effects, not after. Where does this asymmetry come from? The fundamental laws of physics, as we understand them, are mostly time-symmetric. Run them forward or backward, and they still work. If you record a simple physical process and play the video in reverse, the reversed version is just as consistent with the laws of physics as the original. So why does time appear to have a direction? The answer physicists usually point to comes from thermodynamics and from a concept called entropy. Entropy is, roughly speaking, a measure of disorder. Ordered states have low entropy. Disordered states have high entropy. The second law of thermodynamics says that in an isolated system, entropy tends to increase over time. This gives time a clear orientation. The future is the direction where entropy increases, while the past is the direction where entropy was lower. But here's the deeper puzzle. Why was entropy low in the past at all? The fundamental laws of physics don't answer this, because they're time-symmetric and don't favor low entropy in the past any more than in the future. The usual explanation is what physicists call the past hypothesis. It's the assumption that the early universe, near the Big Bang, began in an extremely low entropy state. From that initial condition, entropy has been rising ever since, giving rise to our arrow of time. Recent research from 2024 has linked this idea to quantum mechanics and a process known as decoherence. This is the mechanism by which quantum superpositions turn into states that look classical. Some researchers argue that the arrow of time emerges from the combination of the past hypothesis with the way entanglement and decoherence evolve at the quantum level. So what does this imply for the block universe? It means that even within the block, there is a direction, not because the block is missing an end, but because the arrangement of events inside it is asymmetric. One direction has lower entropy than the other. Memories and records all point that way, and causation operates in that direction. The block universe doesn't deny the arrow of time. It simply says that the arrow comes from the structure of events within the block rather than from the idea that the future doesn't exist or that time literally flows. Think of a landscape painting. The image might show a river running from the mountains down to the sea, clearly indicating a direction of flow from higher to lower ground. Yet the painting itself is static. The flow is a pattern inside a still image. The arrow of time in the block universe works the same way. It's a pattern within a fixed four-dimensional structure. The pattern is real. The asymmetry is real. But none of this requires time itself to flow. To understand how we got here, it helps to look at how these ideas developed, because the history is almost as interesting as the concepts. Before Einstein, time seemed straightforward. In Newtonian physics, time was absolute and universal, with everyone agreeing on what now meant. Time was treated as a dimension, but a special one, distinct from the three dimensions of space. Philosophers argued about whether the past and future truly existed, but this was mostly metaphysical, since physics itself had little to say. In 1905, special relativity changed everything. Einstein showed that time is not absolute. Observers moving relative to one another disagree about simultaneity, and there is no single universal present. This was a radical shift, though its full implications took years to be appreciated. In 1908, Minkowski introduced the mathematical framework of four-dimensional spacetime, making it clear that space and time form a single unified structure, and that events are points within it. Minkowski himself didn't fully explore what this meant philosophically for the nature of time. In 1915, general relativity extended the picture to include gravity and curved spacetime. The math grew more complicated, but the core message remained the same. Spacetime itself is fundamental. It wasn't until the 1960 seconds that philosophers seriously began working through what relativity implies for the reality of the past and future. In 1966, C.W. Reed-Dyke published a paper titled "A Rigorous Proof of Determinism Derived from the Special Theory of Relativity" in the journal Times Philosophy of Science, **. He argued that special relativity implies that events we call future are just as real as those we call past, because for some observers, those future events already lie in the past. In 1967, Hilary Putnam published Time and Physical Geometry in Times the Journal of Philosophy **, developing a similar line of reasoning. Putnam argued that special relativity strongly challenges presentism, the view that only the present exists. These papers triggered decades of debate. Some philosophers accepted the arguments and embraced the block universe, while others pushed back, claiming that relativity doesn't force those metaphysical conclusions. Reed-Dyke and Putnam drew the lines, but the discussion continues today. In 2021, Yaron Sheffer published a paper in Times Research Notes of the American Astronomical Society Times, offering a critical analysis of the Andromeda Paradox, arguing that the usual metaphysical conclusions drawn from it are not as straightforward as they're often presented. The physics of special relativity isn't in question. The equations work, and the relativity of simultaneity is real. Whether this commits us to the block universe interpretation remains a philosophical issue. What can be said is that many physicists, when they think carefully about relativity, find themselves drawn towards some version of the block universe. The mathematics suggests that space-time is a unified whole, and that the distinction between past, present, and future isn't built into the equations themselves. Physics alone may not be able to resolve the metaphysical questions, what truly exists is ultimately a philosophical matter, and the answers may require reasoning that goes beyond what physical equations can provide. Now, let's consider some of the implications of the block universe if it turns out to be accurate. One important implication concerns identity and persistence. In everyday life, we assume that the you of yesterday and the you of today are the same person, that you persist through time. But in a block universe, there isn't really a you moving through time. Instead, there is a world line, a four-dimensional thread through space-time that contains all the successive stages of your existence. Each stage is linked to the next through physical and psychological continuity, but no stage is actually traveling to the next. What makes these stages the same person isn't some enduring substance that moves through time. It's the fact that they are appropriately connected via causation, memory, and physical continuity. This may sound abstract, but it has concrete consequences for how we think about survival and death. In a presentist view, when you die, you cease to exist. The you that was there is gone, and the present marches forward without you. In the block universe view, death works differently. Your world line has a final point, a last moment, but that moment doesn't vanish. It exists at its coordinates in space-time, and the you at death exists in the same way that the you at birth exists. Both are part of the block. Does this mean you're immortal? Not in any practical sense. Your world line is finite, with a limited number of moments. Beyond the final moment, there's nothing more. But it does suggest that existence is more permanent than we typically think. The moments of your life aren't lost as they pass. They remain in the four-dimensional structure forever. Einstein himself seemed to find some solace in this idea. Recall his letter to the Besso family, in which he described the distinction between past, present, and future as a persistent illusion. He wrote to comfort them after Besso's death, implying that in some sense, Besso's existence continued within the structure of space-time. Whether you find this comforting or unsettling depends on your temperament. Some people find reassurance in the permanence. Every moment lived, every experience had, is preserved in the block. Others may find the lack of genuine flow troubling, wondering what purpose exists if everything already is, and what there is to strive for. These are profound questions, and physics alone cannot answer them. The block universe, if true, tells us about the structure of reality, but its meaning for our lives is something each of us must interpret individually. Let's return to the human scale for perspective, because it's easy to lose sight of how extraordinary this is. You woke up this morning, had breakfast, and are now watching or listening to this. These seem like ordinary experiences happening in ordinary time, one after another. Yet, in the block universe picture, each of those moments is a point in a four-dimensional structure, each existing at its own specific coordinates in space-time, each as real as the others. The you who woke up this morning exists at those coordinates, having that experience. The you reading this exists at these coordinates, having this experience. Neither is more real than the other. Both exist. The feeling that this moment is special, that it's now, occurs at every point along your world line. Each moment feels like now, from within. When I first truly understood this, I had to sit quietly with it for some time. It transforms your perspective on time, not necessarily in practical terms, since you still plan for the future and remember the past, but in an existential sense. The texture of experience feels different when you think about it this way. Now, let's consider something that might seem like an objection: quantum mechanics. Quantum mechanics governs the very small atoms, particles, and photons, and is famous for introducing randomness and uncertainty. Particles don't have definite properties until they're measured, and outcomes are probabilistic rather than strictly deterministic. Some people suggest that quantum mechanics could support presentism and an open future. If the future is genuinely random and not predetermined, perhaps it doesn't exist yet. In this view, quantum mechanics might imply that the block universe is incomplete. This is a complicated topic, and physicists don't all agree. Here's a fair summary. Quantum mechanics does introduce what appears to be fundamental randomness. When you measure a quantum system, the result is one of several possible outcomes, with probabilities set by the system's state, and no one can predict with certainty which outcome will occur. But this doesn't necessarily contradict the block universe. The block universe simply asserts that whatever happens is part of the four-dimensional structure. It doesn't claim that events are predictable beforehand. In this picture, the quantum measurement and its outcome exist at specific coordinates in spacetime. The outcome is real, but that doesn't mean it was knowable before it occurred. Consider a coin flip. The result, heads or tails, is random. You can't predict it, but once it happens, it becomes part of history. The future in the block universe works similarly. Quantum randomness might prevent prediction, but it doesn't mean the future isn't real. It simply means we don't know what it is until we arrive there. This is subtle, and interpretations differ. Some, like the many worlds interpretation, align closely with the block universe. All possible quantum outcomes exist, each in its own branch of the wave function, creating an even more expansive version of the block universe. Other interpretations, such as certain forms of the Copenhagen interpretation, are less clearly compatible. They hold that quantum outcomes only become definite upon measurement, suggesting that future events don't yet have determined outcomes. This remains an active area of research, and the relationship between quantum mechanics and the block universe isn't fully settled. Still, I don't think quantum mechanics outright disproves the block universe. The reality is more nuanced. Now, consider something that may seem mundane, but is deeply connected to these ideas. Why do we remember the past and not the future? It's a strange question. Of course, memory records past events. But in the block universe, both past and future exist. So why does access seem limited to one direction? The answer ties to entropy and the arrow of time. Memories are physical records, patterns in the brain, states of neurons that correlate with past events. These patterns form because past events causally influence the brain. For such records to arise, there must be a direction of increasing entropy. Records and memories are examples of low-entropy structures, ordered patterns that carry information about other events. To form these patterns, you need to begin from a low-entropy state. That's why memories point toward the past. It's the direction of lower entropy, the source of order, while records form along the direction in which entropy increases. If entropy decreased toward the future, we would remember the future instead. Our memories would contain events that, from our current perspective, haven't occurred yet. It sounds strange, but physics allows it. Our universe simply sets boundary conditions with low entropy in the past rather than the future. This explains why memory doesn't contradict the block universe. Memory isn't a measure of what exists versus what doesn't. It's a physical process generating correlations along a specific temporal direction. That direction is dictated by the thermodynamic arrow of time. In the block universe, both past and future exist. Yet our brains, as physical systems embedded within the block, form correlations primarily with the low entropy direction we call the past. This idea takes time to fully grasp. Our experience of time is immediate and fundamental, so it feels as though it must reflect something intrinsic about reality. But the notion that memory is merely a thermodynamic phenomenon, that our sense of the past stems from entropy conditions rather than a direct view of what truly exists, is deeply counterintuitive. Counterintuitive doesn't mean wrong. Some of the most profound discoveries in physics have defied intuition. The Earth orbiting the Sun, quantum mechanics, even relativity itself. Reality often differs from what our daily experience suggests. Let's turn to cosmology, because it adds another layer to this discussion. Our current cosmological model describes a universe that began in a hot, dense state about 13.8 billion years ago, which has been expanding and cooling ever since. This is what we call the Big Bang. According to this model, time has a beginning. There was a first moment, or at least something approaching a first moment. Before that, the laws of physics as we know them break down, and we can't describe what came before. What does this mean for the block universe? If the universe has a temporal beginning, the block isn't infinite in the past. There's an edge to space-time, a boundary where things start. This might seem at odds with the block universe, but it isn't. The block universe simply says that space-time is a four-dimensional structure, and all events within it are equally real. It doesn't require the structure to be infinite in all directions, and the block can have edges or boundaries. Cosmologists often describe space-time in block universe terms, showing the history of the universe from the Big Bang to the far future as a single, four-dimensional structure. In this sense, cosmology reinforces the block universe. General relativity, which underpins cosmology, naturally treats space-time as a unified entity. Cosmologists don't usually think of time as flowing. They think of space-time as existing. Cosmology also raises interesting questions about the far future. Does it exist yet? In the block universe, yes. If the block includes all of space-time, it contains not just the Big Bang, now and next year, but also events billions of years ahead. The universe's eventual fate is already part of the block. This can seem strange. How can events that won't happen for billions of years already exist? Remember, in the block universe, already and not yet are observer-dependent perspectives tied to a particular point along a world line. Some events are in the past relative to that point, others in the future. The block as a whole simply exists without a dividing now. The far future exists in the same sense as the far past. We just happen to occupy a specific location in the block, unable to perceive distant events directly. Another common concern is whether we can change the future. It might seem obvious that we can't if the future already exists in the block, but this is a subtle point. In the block universe, the future is determined in the sense that it has definite content. Facts about tomorrow exist just as facts about yesterday do. That doesn't mean your choices don't matter. Your decisions are part of the block. When you act, Your actions influence later events, shaping the future. The block universe doesn't override your choices. It includes them. For example, imagine deciding whether to have coffee or tea tomorrow. If you choose coffee, the block contains you deciding coffee. If you choose tea, the block contains you deciding tea. The block doesn't make the choice for you. Your decisions determine the structure of the block. This distinction is subtle but important. The block universe is not fatalism. Fatalism suggests choices don't matter. The block universe says they matter profoundly, because they are what give the block its shape. The difference between the block universe and everyday thinking isn't whether choices have effects, but how those choices relate to what exists. In everyday terms, choices determine a future that doesn't yet exist. In the block universe, choices are part of a timeless structure. In both perspectives, choices remain causally effective. It's also fair to consider alternatives to the block universe. Not everyone who understands relativity accepts eternalism. One alternative is the growing block theory. Here, the past and present exist, but the future does not. The block is not complete. It grows as time passes, with new events coming into existence and being added to the block. This preserves the sense of an open future that genuinely doesn't exist yet, while acknowledging that the past exists and past events aren't gone. The growing block theory faces challenges from relativity of simultaneity. If there's no objective now dividing existence, then where does the block's edge lie? Different observers would disagree on the boundary, suggesting it isn't objectively real. Proponents of the growing block have proposed various responses to this challenge, but it remains a debated topic in philosophy of time. Some philosophers suggest there could be a privileged foliation of spacetime, a specific way to slice it into moments that represents the true boundary of existence, even if observers can't detect it. Others have developed more nuanced views that try to reconcile this with relativistic effects. Another alternative is presentism, the idea that only the present exists. According to presentism, past events have ceased to exist, future events do not exist yet, and only the instantaneous present is real. Presentism aligns closely with our everyday experience. The present feels special, the past seems gone, and the future feels open. But presentism struggles more with relativity than the growing block theory. If only the present exists, and relativity shows that now is observer-dependent, then what exists would depend on the observer. Different observers in motion relative to each other would experience different realities, which is problematic. Presentists have proposed responses. Some posit a privileged frame that defines the true present, even if relativity doesn't reveal it. Others try to reformulate presentism to avoid this issue. These debates are ongoing and unresolved. The block universe is not the only option, and intelligent thinkers disagree. Physics alone may not settle these metaphysical questions. That said, many physicists take the block universe seriously because it fits naturally with the mathematics of relativity. Special and general relativity describe a four-dimensional space-time rather than a three-dimensional space evolving in time. The mathematics suggest space-time is fundamental. Philosophy comes into play in interpreting the equations, which can be read in multiple ways. What would it mean if the block universe is true? I've touched on some implications, but let's explore further. If the block universe is correct, your entire life already exists. Every moment, From birth to death, every choice, every experience, every success, failure, joy, and sorrow, all are embedded in space-time. This might feel like being a character in a story that's already been written. And in a sense, that's true. You are a character experiencing the story from within, making choices that feel real and living each moment as if it were new. The deeper question is, which perspective is more fundamental? Is the outside view, where the entire block exists at once, the ultimate reality, with the inside view being an illusion? Or are both perspectives equally valid, simply different ways of relating to the same reality? I tend to think both are real. The block exists as a whole, and that's a fact about reality. At the same time, you genuinely experience time from within, and that experience is not a mistake or illusion. It's simply what it's like to be a conscious being at a particular point in the block. Think of it like spatial perspective. From your position, some things are in front of you, some behind. That's real, your actual perspective. There's also a view from nowhere, a description of where everything is without privileging any location, which is also real. Similarly, in time, there may be both your temporal perspective, with past and future, and the view from now, where the entire block is laid out without privileging any moment. Both perspectives are valid, offering different ways of describing the same reality. Reflecting on my own life through this lens is revealing. When I think about past experiences, both good and bad, I remind myself that in the block universe, those moments still exist. The joy of a beautiful day years ago isn't gone. It exists at its space-time coordinates, just as real as today. When I think about the future, it's already part of the block from a certain perspective. My uncertainty about what will happen is a feature of my perspective, not the structure of reality itself. Thinking about mortality also shifts. My world line has an end in space-time, but ending a world line isn't the same as erasing it. The moments of life remain part of the block, even after the world line ends. Practically, this doesn't change my planning, my memories, or the experience of time passing. But the block universe offers clarity, a reminder that our everyday way of thinking about time, while natural and useful, isn't the only way to understand it. Here's a thought experiment to visualize it. Imagine stepping outside space-time and observing it from the outside. You'd see a vast four-dimensional structure containing all events in history, galaxies forming and dissolving, stars igniting and burning out, the entire cosmos laid out as a single, complete tapestry. Planets forming from cosmic dust, life emerging and evolving, civilizations rising and falling. Running through this whole structure are the world lines of every object and being. Your own world line would appear as a thin thread linking your birth to your death. You'd see your entire life laid out, every moment you've lived and will live, from the perspective of someone observing the whole structure at once. From this outside viewpoint, there is no flow. The structure simply exists. Every event is equally present, equally real. The distinctions we make between past, present, and future vanish from this vantage. Since these distinctions are features of perspective rather than intrinsic properties, you cannot actually step outside space-time. Naturally, you're embedded within it, and your perspective is necessarily internal. This thought experiment helps illustrate the block universe's claim. Even if the external perspective is inaccessible, it remains a valid description of reality. Here's another way to think about it. Imagine meeting someone from the distant future within the block universe. This person already exists, occupying their coordinates in space-time, living their life just as you live yours. The fact that you cannot currently interact with them does not negate their existence. They are simply elsewhere in the block. It is strange to consider. Someone who will be born centuries from your point of view is already there, as real as you are now. Their experiences unfold at their location in space-time, with a perspective on time as valid as yours, remembering what for you is the far future as their past. Meeting them would be disorienting. They are from your future, yet from their perspective, they are entirely present. Both your now and theirs exist simultaneously within the same structure. To put this in scale, the visible universe spans roughly 93 billion light-years in diameter, the part we can, in principle, observe given the universe's age and the speed of light. In meters, this is approximately 8.88 times 10 to the power of 26 meters. The universe's age is about 13.8 billion years, or roughly 4.35 times 10 to the power of 17 seconds. These numbers describe the observable universe in space and time. Yet the block universe extends beyond what we can see. The future of the universe, whatever it holds, is already part of the block. Regions beyond our current horizon, outside what we can observe, exist within this structure. The block contains everything, every galaxy we can detect, and every galaxy beyond our sight, every moment from the Big Bang to the far future, all present in the four-dimensional fabric. Returning to the Andromeda Paradox highlights the stakes. The Andromeda Galaxy is 2.5 million light-years away. Two people walk past each other on Earth at relative speeds of roughly 1-2 meters per second. Their disagreement about what is happening now in Andromeda can differ by multiple days. Consider the stakes. An Andromedan war council planning an invasion, a scientist making a groundbreaking discovery, or a couple getting married. For one observer on Earth, these events are in the past, already settled. For another, walking the opposite direction, they lie in the future, not yet realized. Which observer is correct? According to special relativity, both are, or more precisely, the question has no objective answer. Now, in Andromeda, is observer-dependent. Presentists, who hold that only the present exists, face a problem. What exists varies with motion. Accepting the block universe resolves this. All events in Andromeda exist at their space-time coordinates, and simultaneity is observer-relative. What is now depends on perspective, but reality itself is unaffected. This illustrates why the Andromeda Paradox is so striking. Even mundane walking speeds can produce days of discrepancy in what counts as now for distant events. This brings us to the nature of change. In everyday life, we see things changing. The sun rises and sets, people age, buildings are built and demolished. Change seems fundamental, but in the block universe, change is a asterisk pattern within the structure asterisk. At one coordinate, the sun is in one position. At a later coordinate, it is elsewhere. The difference between these states is what we perceive as change. The block itself does not change. It is a static four-dimensional entity. Change exists asterisk within the block, asterisk asterisk, not asterisk asterisk of the block, asterisk asterisk. This may feel at odds with our lived experience. We perceive the world as dynamic, flowing, and constantly evolving. Yet in the block universe, what we experience as happening is the unfolding of relations along our world line, a sequential slicing of a timeless structure that gives rise to the impression of motion and change. Remember, our experience comes from within the block. We are conscious beings located at specific points in spacetime, and at each point, we have experiences, including experiences of change. The experience of change is real, but it's a pattern within a static structure, not proof that the structure itself is changing. This is subtle and worth contemplating. The block universe doesn't deny that change occurs. It simply reinterprets what change is. Change is a difference across time, a pattern within the block. What the block universe rejects is the idea that the block itself evolves or grows. Think of a painting of a river. The brushstrokes suggest motion, ripples, and currents. An observer sees a flowing river, but the painting itself is static, just a canvas with pigments. The flow of the river is a pattern within the painting, not a change in the painting itself. The flow of time in the block universe works the same way. It's a pattern within the static four-dimensional structure, not a change in the structure itself. The pattern is real, and we experience it. But what's truly real is a static block containing the pattern, not a constantly changing reality dictated by a present moment. Here's a question people often ask. If the block universe is true, does anything actually happen? At first, it seems strange. Of course, things happen. You woke up this morning, the sun rose, people were born and died. But the word happen implies process, unfolding, becoming movement from one state to another. In the block universe, that's not quite right. Events don't come into existence. They don't become real. They simply are at their coordinates in space-time. The birth of a child, the death of a star, your reading of this sentence, these are all real events. They exist in the four-dimensional structure. It's fair to say that events exist, but they don't happen if happen means coming into being. They simply are. This is a philosophical subtlety, but it captures a key insight of the block universe. Reality is a static structure, not a dynamic process. Now, let's connect this to some timeless human questions about mortality and meaning. Humans have always wondered what happens after death. Every culture has its stories of what lies beyond, from afterlives to rebirths to final ends. The block universe offers its own perspective. Here, death is the end of a world line, the last moment along a finite thread in space-time. The thread doesn't vanish. Every moment leading up to death remains at its coordinates in the block. This might feel like cold comfort. You can't return to those moments or relive them. They exist, but you don't access them. And your consciousness, whatever it is, doesn't persist beyond the end of your world line. Or does it? This is where things get philosophically murky. What is consciousness? How does it relate to each moment along a world line? If every moment exists in the structure, does the consciousness at each moment exist too? These are questions physics alone cannot answer. They touch on the hard problem of consciousness, on the nature of subjective experience, and on what it means to be a self persisting through time. Some people find comfort in the block universe view despite these uncertainties. Even if consciousness doesn't persist, the moments of life do. Your happiest days exist in space-time forever. Your hardest days exist too, but they don't erase the good. Everything is preserved. Others find no comfort. What good is eternal preservation if you can't experience it? What value is there in the existence of past moments if the you who lived them is gone? I don't have definitive answers to these questions. They are among the deepest humans can ask. What I can say is that the block universe provides a framework for exploring them, a context in which to pose these questions, even if we cannot answer them fully. Finally, consider something fascinating about human perception of time. It is not a simple, direct observation. Our brains construct our experience of time using memory, anticipation, and the dynamics of neural processing. What we perceive as the flow of time is a narrative our mind creates from patterns in the block universe. Researchers have identified what's called the specious present, a brief window of time, maybe 2 to 3 seconds, that feels like now to us. Within this window, events feel simultaneous and present, while outside it, events feel like past or future. The specious present is not the same as the physical present. The physical present, to the extent it exists, is an instant, a zero-duration point in time. The specious present, by contrast, is an extended window of awareness. What this means is that even our experience of now is a construction. It is not a direct perception of some objective instant, but a synthesis performed by our brains, which weave together inputs that actually arrived at slightly different times into a unified sense of the present. Neuroscientists have discovered time cells in the hippocampus and entorhinal cortex that fire in sequence, tracking the passage of time. These neural structures underpin our sense of duration and our ability to situate events in time. All of this happens inside our heads. The experience of temporal flow, the sense that the present becomes the past as new moments arrive, is a feature of conscious experience, not necessarily a feature of external reality. In the block universe, this makes perfect sense. If all of space-time exists as a static structure, then the experience of flow must be generated from within conscious minds at specific locations along their world lines. The flow is real as an experience, but it does not reflect something objective about the external structure. This is strange to contemplate. The most basic feature of our conscious experience, our sense that time passes, might not correspond to anything out there. It might simply be an artifact of how our brains process information. Yet strange does not mean false. Many aspects of reality are counterintuitive, and the block universe, for all its strangeness, offers a coherent picture of how physics and experience fit together. Let's ground these ideas with some numbers and scales, which help make the abstractions concrete. The speed of light is exactly 299,792,458 meters per second, not an approximation, but a definition. Since 1983, the meter has been defined in terms of the speed of light. In other units, that's about 186,282 miles per second. Light could circle the Earth about 7.5 times in a single second. In an hour, light travels roughly 1.08 billion kilometers, 670 million miles. In a year, it travels about 9.46 trillion kilometers, 5.8 1.8 trillion miles, the distance we call a light year. These numbers are crucial because they set the scale for relativity. Special relativity effects become noticeable when speeds approach a significant fraction of light speed, or when distances are so large that light takes substantial time to travel. Consider the Andromeda galaxy, 2.5 million light-years away. That's about 2.365, 10, 22. 2.365 times 10, 22 meters, or 1.47, 10, 19, 1.47 times 10, 19 miles. To imagine this, traveling at the speed of light, it would take 2.5 million years to reach it longer than our species has existed. Even at these cosmic scales, relativity produces striking effects. Two observers walking past each other, differing in velocity by just 1 meter per second, is approximately equal to 2.2 miles per hour, would disagree about what's happening in Andromeda by about 3.05 days. The calculation comes from the Lorentz transformation for simultaneity. Delta, nBert, 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 delta, nBert, nBert. 2. Deltat is approximately equal to c. 2 ved deltax for south at then, with nBert. 1. V equals 1 meter per second, delta, nBert. 2.365, 10, 22. Deltax equals 2.365 times 10, 22. M, and nBert. 299, 792, 458. C equals 299,792,458 meters per second. We get delta nBert 263,000. Deltat is approximately equal to 263,000 seconds, roughly 3.05 days. If they walk faster, at 1.4 meters per second to 3.1 miles per hour, the disagreement grows to 4.26 days. These are precise predictions, not approximations. Compare this to familiar scales. Across Earth's diameter, 12,742 kilometers, or 7,917 miles, the same 1 meter per second relative speed gives a simultaneity difference of just 0.142 nanoseconds, far too small to detect. This is why we never notice relativity of simultaneity in everyday life. The effect only becomes significant across cosmic distances. Let's explore a thought experiment. Imagine creating a perfect copy of yourself, atom for atom. This copy has all your memories, personality, and intentions. It feels like you from the inside. From the block universe perspective, the original you has a world line from birth to death. The copy begins its world line at the moment of copying. Are these two beings the same person? Each feels like themselves, but they occupy different space-time locations, and their world lines diverge after the copying. They share a past, but the future for each is distinct. This thought experiment raises deep questions about personal identity. What truly makes you, you, from one moment to the next? Is it the continuity of your body, your memories, or your consciousness? In the block universe, each moment along your world line is a distinct event with its own coordinates in spacetime. What unites all these events into your life is the causal and psychological connections between them. These connections exist within the block itself, rather than depending on some flowing time that carries your identity along. Here's another thought experiment. Imagine two observers, Alice and Bob, moving relative to each other, and each describing what's happening in the Andromeda galaxy. Alice says, "Right now in Andromeda, it's the 15th of March, 2025, Andromeda time." Bob, walking past Alice in a different direction, says, "Right now in Andromeda, it's March 20, 2025, Andromeda time." They're both using the phrase "right now," but they mean different things. For Alice, right now selects one set of events. For Bob, it selects a different set. Neither is wrong. According to special relativity, there is no absolute answer about which events are simultaneous with their meeting. Simultaneity is relative. If Alice is a presentist, believing that only the present exists, she must hold that March 15 events exist while March 20 events do not. Bob, also a presentist, would claim the opposite. Both cannot be correct if presentism is true. Yet both are perfectly valid observers, following the laws of physics. This is the essence of the Wright-Dike-Putnam argument. The relativity of simultaneity seems to suggest that existence itself cannot be observer-dependent. If both Alice and Bob are describing the same reality, then all of those events must exist. This puts real pressure on presentism, which is why many physicists and philosophers are drawn toward the block universe view. Another common question arises. If the block universe is true, why do the laws of physics appear to operate in time? After all, Newton's laws, or Schrödinger's equation, are written as differential equations describing how things change over time. They seem to assume that time flows and systems evolve from one state to the next. This appearance can be misleading. The laws of physics can instead be understood as constraints on the four-dimensional structure of spacetime. They don't describe evolution so much as define patterns that must hold throughout the block. For example, Newton's first law states that an object in motion stays in motion unless acted upon by a force. In a flowing time view, this means the object keeps moving moment by moment. In the block universe view, it means the object's world line is a straight line through space-time, unless a force acts. The law constrains the shape of world lines, rather than describing a step-by-step evolution. Mathematically, these interpretations are equivalent. The equations and predictions are the same. Conceptually, however, the block interpretation is often more natural, especially in general relativity, where the equations describe the geometry of spacetime as a whole. Using initial conditions to compute later states is just one way to apply the equations. You can also see the equations as describing the entire four-dimensional solution at once. This is why the block universe does not conflict with the existence of physical laws. The laws are part of the block, determining its structure and constraining which patterns can exist. They do not require time to flow in a literal sense. It's also worth looking at the history of these ideas. Newton's physics, with its absolute time, was the culmination of centuries of progress. It gave a framework that worked spectacularly well for describing motion and gravity, serving as the foundation of physics for over 200 years. Then, Einstein challenged assumptions that seemed unquestionable. Working in a patent office as a young man, he took the constancy of the speed of light seriously and worked out the consequences. The result was a radically new picture of space and time. overturning Newtonian intuition. This pattern repeats in the history of physics. What seems obvious and fundamental often turns out to be approximate, limited, or misleading. True progress comes from questioning what everyone takes for granted. The block universe is partly a result of taking Einstein seriously. If special relativity is correct, and if simultaneity is relative, then our intuitive picture of time as a flowing river of moments is incomplete at best. Physics suggests something more like a frozen landscape, where all moments are equally real. This idea is uncomfortable. It defies deep intuitions and challenges how we think about time and our place in it. But discomfort does not imply falsehood. History shows that reality often does not align with our expectations. The block universe might feel strange, but it emerges naturally from the physics, and sometimes physics asks us to rethink even the most basic features of experience. The Earth is not the center of the universe. Objects are not solid, but mostly empty space. Time is not absolute, but relative. Time and again, science has shown that our intuitions, however compelling, can mislead us. The block universe may be another such lesson. Our experience of flowing time, vivid and undeniable as it is, might be like the apparent solidity of objects, real in experience, but not reflecting the fundamental nature of reality. Let me share some personal reflections before we move toward closing. When I think about the block universe, I oscillate between different responses. Sometimes it feels liberating. All of time exists. Nothing is lost. The moments of joy in my life, past and future, are preserved in the structure. They're not gone just because I'm not experiencing them right now. Sometimes it feels constraining. If everything is already there, what am I doing? What's the point of effort or decision? That feeling usually passes when I remember that my efforts and choices are part of the structure. They help determine how the block is arranged. Yet other times, it feels utterly alien. The idea that I exist as a four-dimensional thread in space-time, that my sense of flow is merely a pattern in a static structure, that the distinction between past and future is an artifact of perspective. It all feels so far from how I actually experience life. Occasionally, I catch a glimpse of the view from outside, a sense that everything is there, spread out, complete, a sense that the urgency and momentum of ordinary experience are just one way of being, and that there's another, timeless way, where everything simply is. These glimpses don't last. I'm too embedded in my temporal experience, too caught in the flow of moments to sustain the eternal perspective. But they are enough to make me suspect that the block universe might be pointing at something real. I offer these reflections not as arguments, but as testimony. This is how engaging with these ideas has affected me. Your response might be entirely different. The ideas are there for you to wrestle with yourself. Before we close, let's touch on one more piece of physics. The Lorentz transformation, which describes how space and time coordinates transform between observers in relative motion, contains the key to the relativity of simultaneity. The formula is precise. Mand, 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 dias. Mand, 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 2, das, equals gamma, c, 2, vx. And first in Castor, where mand, gamma is the Lorentz factor for two events separated by distance. Delta, mand, Deltax, the difference in simultaneity assignments between frames moving at relative velocity. Mand, v is approximately delta, mand, mand, delta, mand, mand. 2. Deltat is approximately equal to c, 2, v deltax, and first in casture. This formula underpins everything we've discussed. It explains why moving observers disagree about what is happening far away, why the Andromeda Paradox works, and why the intuitive idea of a universal present fails. The formula has been tested millions of times in particle accelerators, in satellite navigation systems, in precision experiments of all kinds. The physics works. It is not in question. What is in question is what it means. That's where physics meets philosophy, where equations meet interpretation, where the hard work of understanding reality truly begins. One thing I think is often misunderstood is the difference between what physics shows and what physics suggests. Physics shows that simultaneity is relative. Different observers in relative motion assign different times to distant events. This is tested, confirmed, and undeniable. Physics suggests, but does not prove, that this implies the block universe. The mathematical structure of spacetime naturally lends itself to a four-dimensional interpretation, but one can, in principle, resist this conclusion. Presentism, or the growing block view, can, with effort, accommodate the physics. The debate between these positions is philosophical rather than strictly physical. The physics itself doesn't change across interpretations. What differs is the metaphysical picture we build around it. This distinction is important. When I say the block universe is taken seriously by physicists, I'm not claiming it has been proven by experiment. Rather, it is a natural interpretation of the physics, one that many experts find compelling. But it remains an interpretation, subject to philosophical debate. Intellectual honesty demands acknowledging this. The block universe is not established fact in the same way that the relativity of simultaneity is. It is an inference from that fact, and inferences can be questioned. That said, I personally find the block universe interpretation more convincing than its alternatives. The mathematics of spacetime genuinely seems to describe a four-dimensional structure. Attempts to preserve presentism in light of relativity feel strained to me. Reasonable people can disagree, and it's important not to pretend the debate is settled when it isn't. Let's summarize what we know and what we don't know. What we know. Special relativity implies that simultaneity is relative to the observer. There is no universal now shared by all observers. Events that are simultaneous for one observer may not be for another. The mathematics of relativity describes a four-dimensional spacetime, not a three-dimensional space evolving in time. What we don't know, whether the relativity of simultaneity implies that past and future are equally real, whether the block universe is the correct interpretation of the physics, whether alternative interpretations can preserve more of our intuitive experience of time while still accommodating the physics. What we do experience time flowing, the present feeling special, the past seeming fixed, the future seeming open, is real. That is not a matter of interpretation. It is what our consciousness tells us. Here's another way to look at what all this might mean. One perspective is humility. Our usual experience of time, with its urgent present and open future, is parochial, tied to our location in space-time. Our particular psychology and our temporal perspective. The block universe invites us to imagine a broader view, one not tied to any specific moment. From this vantage, all of history is spread out, equally real and equally present, and the urgency of now is simply a feature of where we happen to be located. This might feel like it diminishes the importance of the present. If everything already exists, if the future is just as real as the past, why should now matter? I think that's a misunderstanding. The present matters to you because you are here experiencing it. The fact that other times exist elsewhere in the block doesn't make your current experience any less real or meaningful. It's similar to asking why the place you occupy matters when other places exist. Other places do exist, but that doesn't make your location any less significant. Other times exist too, but that doesn't make the moment you are in any less significant. The block universe doesn't tell you not to care about the present. It simply situates it in a larger context. Your experience of now is one perspective among many, one point in a vast structure. That's humbling, but it doesn't diminish the reality or importance of the present. Let's consider how people often respond emotionally to the block universe. For some, it can feel disturbing. It seems to suggest that the future is fixed, that our choices don't matter, that we are merely puppets following a predetermined script. This can lead to feelings of helplessness or despair. But I think this reaction is based on a misunderstanding. The block universe says the future exists, but it does not say your choices are meaningless. Your decisions are part of what shapes the block. If you choose differently, the block itself would be different. The block universe is fully compatible with a strong sense of agency. You make choices. Those choices have consequences. You are responsible for your actions. What changes is the metaphysical picture of how your choices relate to the structure of reality, not the fact that your choices matter. Instead of your choices determining a future that doesn't yet exist, the block universe sees your choices as part of a structure that exists timelessly. Both perspectives give your actions the same practical significance. The difference lies in the metaphysical background, not in the importance of what you do. For some, the block universe is strangely comforting. If all of time exists together, then nothing is ever truly lost. The joyful moments of your life remain in space-time forever. People you have loved and lost still exist at the coordinates of their existence. The past is preserved. This might not alleviate grief in any practical sense. You cannot relive those moments or see those people again. But for some, knowing that these moments and people still exist as part of the structure brings consolation. Einstein, for instance, seemed to find comfort in this perspective when writing to the Besso family. The idea that the distinction between past, present, and future is an illusion may have allowed him to see death not as an ending, but as a transition, a shift from one part of the block to another. For others, the block universe is simply fascinating, an intellectual puzzle that challenges assumptions without carrying much emotional weight. It's a way of looking at the world that stretches your understanding without threatening your daily life. I think all these responses are valid. How you react to the block universe likely depends on your temperament, your values, and your prior beliefs. The concept is rich enough to support multiple emotional responses. What isn't valid, in my view, is refusing to engage with it simply because it feels uncomfortable. Reality doesn't care about our comfort. If the block universe is true, it is true, regardless of how we feel. Our task is to understand, not to choose metaphysics based on what feels nice. One more subtlety is worth clarifying: the distinction between the block universe and determinism. These ideas are often conflated, but they are not the same. Determinism states that given the state of the world at one time, the laws of physics uniquely determine the state at all other times. The future is fixed by the past plus the laws. The block universe, on the other hand, says that all of time exists together, with the future existing just as the past does. It doesn't claim that the future is determined by the past. It simply exists. You could, in principle, have a block universe that is not deterministic. Quantum mechanics, for example, involves genuine randomness. The outcome of a quantum measurement isn't determined by what came before. Whatever the outcome, it is part of the block and exists at its space-time coordinates. Conversely, one could accept determinism without committing to the block universe. A presentist could believe that the past determines the future, even if only the present exists. The future is fixed in that sense, but it hasn't yet existentially arrived. Determinism and the block universe are logically independent. Accepting one doesn't force you to accept the other. In practice, though, those who lean toward one often find the other appealing because the ideas have a family resemblance. They are related, but not identical. This distinction matters because many objections to the block universe are really objections to determinism. If the future already exists, I have no freedom, really means, if the future is fixed by the past, I have no freedom. The block universe doesn't make this claim. It doesn't say the future is determined by the past. It merely says that the future exists. Whether freedom is possible in a block universe depends on what you mean by freedom. If freedom requires a genuinely open, undetermined future, then the block universe might be in tension with that. But if freedom simply means that your choices have causal efficacy and can influence what happens, then the block universe is fully compatible with freedom. These are deep questions in the philosophy of free will, and I won't attempt to resolve them here. My point is that the block universe does not automatically settle questions of freedom. There's still more work to be done. With that, let's draw this exploration to a close. We've covered a lot of ground. We began with two people walking past each other on a sidewalk, disagreeing by days about what's happening right now in a distant galaxy. We traced the physics of special relativity, the constancy of the speed of light, the relativity of simultaneity. We explored the four-dimensional space-time picture developed by Minkowski and expanded by Einstein in general relativity. We examined the block universe interpretation, the idea that past, present, and future are all equally real, that space-time exists as a four-dimensional structure all at once, and that the passage of time is a feature of perspective, not an objective flow. We went through the arguments supporting this view, particularly the Wright-Dike-Putnam argument about what relativity of simultaneity implies. We acknowledged the critiques and alternatives, the ongoing philosophical debates, and the questions that remain unsettled. We considered the arrow of time and entropy, the nature of change within a static structure, and the relationship between experience and physics. We explored what all of this might mean for free will, for mortality, and for how we understand our own lives. Through it all, one thing has remained constant: the sheer strangeness of time. Whatever the correct metaphysical picture turns out to be, time is not what our everyday experience suggests. Physics has revealed depths and complexities that our intuitions could never have anticipated. Einstein was right in at least one sense. The distinction between past, present, and future is not as clear-cut as we thought. Whether it is a persistent illusion, as he suggested, or something more nuanced, the naive idea of time as a flowing river has been complicated beyond recognition. I find this humbling. We walk around thinking we understand time, confident that the present is obviously real and the future obviously open. And then physics tells us our confidence is misplaced, that reality is far stranger than we imagined. I also find it exciting. These are deep questions about the fundamental nature of reality. We get to engage with them, to think about them, to be conscious beings asking what time really is. That is a privilege. Not everyone who has ever lived has had access to these ideas, or the education, or the leisure to contemplate the structure of space-time. The fact that we can think about these things, follow the arguments, and glimpse the possibilities is something to appreciate. Wherever you are right now, whatever moment you're experiencing, you are a point in the structure of space-time, your consciousness illuminating this particular location in the four-dimensional manifold. The moments before this one are at their coordinates, and the moments after are at theirs. You don't know what comes next. From your perspective, the future is unknown, waiting to be discovered. You will experience it moment by moment, just as you are experiencing this moment now. If the block universe is correct, though, then in some sense the next moment is already there. Your tomorrow already exists. Your next year already exists. Everything that will happen to you is already part of the structure. This might feel frightening. It might feel comforting. It might feel neither. It simply is the way things are. Even if the block universe isn't entirely right, even if another interpretation proves better, the physics stands. Simultaneity is relative. The present moment is not universal, and time is not what it seems. That is enough to provoke wonder, enough to make us pause, reconsider our assumptions, and remind us that reality is vast, strange, and under no obligation to match our intuitions. I hope this exploration has given you something to think about. These ideas reward patient contemplation. They don't reveal their full depth at first glance. They grow richer the more you sit with them. If you found value in this journey, consider subscribing to the channel. There are more explorations like this, more opportunities to engage with deep questions about the nature of reality. We'll continue to learn together, to think together, to wonder together. Thank you for taking this time with me. These ideas deserve careful attention, and I appreciate you giving them that. Tonight, as you move from this moment to the next, I invite you to wonder, what is time really? Is each moment coming into being, or is it already there, waiting for you to arrive? Is the distinction between past and future carved into reality, or is it a feature of your perspective? You won't find definitive answers, but the wondering itself is worthwhile. It's part of what it means to be a conscious being in a universe that physics has shown to be stranger than we ever imagined. Sleep well tonight, and as you drift off, consider this. If the block universe is correct, your tomorrow already exists somewhere in space-time. You just haven't arrived there yet. Good night.